To get started with AWS CDK, the first thing that we need to do is to install it. You need to have Node and npm installed in your machine. And once you have them, you can install CDK by running this command. If this is your first time using CDK, you will need to bootstrap your account first. To do that, you can run this command. What CDK Bootstrap will do is to provision initial resources. Why CDK needs to bootstrap is because when CDK performs deployments, it needs to interact with Amazon S3 bucket for storing files and assets, to creating IAM roles to grant permissions. You only need to do bootstrap one time only, and yeah, don't forget to do this. Next, once that we have our CDK installed and bootstrap, we can start developing with CDK. And one thing that I like from CDK is that it has a command to help us prepare our application. To do that, we can run CDK init command, follow with the programming language that we want to develop the application. Now let me show you how we can build our serverless API. This is the CDK application that I've built for deploying serverless API. There are two files in this folder, CDK and Lambda function. Obviously, Lambda functions holds all AWS Lambda functions that I need to run the API, and CDK is the CDK application. Let's review the AWS Lambda functions to give you a quick overview on how this API looks like. In Lambda functions folder, I have 4 subfolders, each respective to activities that I want to run for my API. They are list data, save data, get data, and delete data. Let's take a look into save data function. This function will be triggered if there's any incoming request with post method. It's going to get the JSON payload from the body and save the data into Amazon DynamoDB. Now to get the list of all data, we also have another function, and that is called list data. In this function, for get request into the endpoint, it will load all the data from DynamoDB and return only the ID of the data. To get specific details from the database, we can pass the ID into getData function. Here, our app performs query into DynamoDB to load all the details based on the ID of the data that we like to get. Lastly, to delete the data, we also have delete data function. And this function will delete the data based on the ID that we pass as input. Now we know all the functions to run our API. The next step is to define the resources using IAC with AWS CDK. This is our main CDK app, and here's the fun begins. In this file, we define all resources we need to run serverless API. Here we import all required libraries. We have Lambda, we have DynamoDB, we have API Gateway, and other required libraries from CDK. This line shows this is a CDK app, and we're going to use this tag. If we go to this declaration, this leads us to the stack that we are going to use to define our serverless APIs. Let's review it one by one. The first thing that we're going to define in the CDK app is the database. The database in this serverless API is using Amazon DynamoDB. And this line shows us how to define the table using Amazon DynamoDB, using this configuration, such as table name, partition key, as well as read capacity and write capacity. Now we need to create permission for AWS Lambda to access DynamoDB. So here we define the IAM role for our Lambda function. First, we'd like to have our AWS Lambda to access CloudWatch logs. So here we define the access to CloudWatch logs. Then we define the access to DynamoDB. We are implementing least privilege for our DynamoDB, which means that we are only providing few actions like put, get, update, and delete item, as well as scan, query, and checking with condition. This role won't allow our Lambda to do any other than these defined actions, ensuring we have security in place. At this stage, we have our DynamoDB and IAM roles. In the next section, we define our AWS Lambda function. The structure is pretty much the same, so let's review for save data function. The first thing that we define here is the code property. The code property refers to the asset code that we have. And as you can see, this is the path to the Lambda functions folder, and it's located here. And this is really convenient, as we can code our infrastructure and code our applications without leaving our IDE or code editor. Next is the main handler function. In this case, it's called as app.handler. Then we also define timeout, and I set it to maximum 60 seconds. Also the role. This is important, as without this, our Lambda functions cannot run properly, as it needs access to DynamoDB and also CloudWatch. Here, we refer to the Lambda role variable that we previously created. Then, we activate the tracing, and this also means we are enabling X-ray that's helpful for us to practice observability and monitoring. And lastly, runtime. I'm using Python 3.8. As these Lambda functions require to connect to DynamoDB, we also need to inject the table name as environment variable, which Lambda functions can easily load. And to do that, we can use add_environment function to inject environment variable into AWS Lambda function. Its key value property, and I'm using table name as the variable name, and the DynamoDB table name that we previously defined. And the same thing applies for the rest of AWS Lambda. So let's go to the next section, and that is API Gateway. To define the API Gateway, I'll be using REST API object from Amazon API Gateway. To integrate the REST API with our Lambda functions, we need to have integration. And in these lines, we have the integration for our Lambda functions and REST API object. And when it comes to REST API, we also need to define how our clients can access all the resources. So let's say that we want to have the client to access the resources using this URL. Then we need to define the data as the path. Then we define the method that we like to integrate with this resource. And sometimes we also need to pass the URL parameters, and we can do that by using this directive. This way, for any request to this endpoint, we'll go to these integrations. And lastly, we need to output the DynamoDB table name as well as the endpoint URL. Okay, so we have our CDK app ready. The next thing that we need to do is to deploy this application. To deploy this app, let's switch back to the terminal and run CDK deploy. CDK is now preparing all the assets and provision resources for us. And after CDK is done processing, we can see the outputs here.